Hello friends, welcome to Unacademy. Today we are going to discuss about Hello friends, welcome to Unacademy. We are going to discuss about entity relational model, very important especially in public sector undertakings. It's a 1 mark damn sure question. Minimum is a 1 mark and the maximum is 2 marks. So in this series of lectures, the first lecture is mainly talking about what is the importance of ER model and what are its advantages and disadvantages, and what are the terminologies which are there in ER model and the components of ER model. So let's learn entity relational model. Let's crack it. Crack GATE computer science with us, top educators, quality content, great learning experience. Let's crack GATE CSE. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures. About myself is Srinivasarao Sir, having 17 years of GATE experience in the subjects of DBMS, networks and operating system. Also had industry experience with the good certifications like DB, Cisco, Microsoft and Red Hat Linux. Throughout my journey of GATE, I taught in many premium academies and I am part to obtain for single and double digit ranks. And my premium academies, which I taught, includes the GATE Forum, GATE Academy, and MadeEasy too. Please, all of you, subscribe to our channel Let's Crack GATE CSE and take the subscription to know shortcut tricks and quality content. If you get the subscription, you will get daily live classes and live tests and quizzes and unlimited access where you will get recorded and live lectures. And using a daily live classes, you can interact with the faculty and clarify your doubts. So there are two kinds of subscriptions available as far as GATE and ESE concerned, 12 months and 24 month subscription. If you opt 12 month subscription, apply my referral code so that you will get 10% off. In the same way, 24 month subscription, you will get it for 27,000 by applying my promo code. Let's crack GATE CSE. Subscribe to YouTube channel, hit the bell icon for latest updates, use my referral code Sankara. So I'm welcoming to the ER model approach. Before entering into ER model, first let us understand how a database can be designed. A database can be designed using different approaches. So one approach is a top-bottom, the other approach is bottom-up, the other approach is combination of top and bottom approaches, famously known as mixed approach. If you look at the top-bottom approach, there are some kind of order before you put the final database in the real world. There is some order we need to follow in top bottom and bottom up. So as far as top bottom concern, you see, first you need to identify what are the type of entities are there, then what are the relations are among them, and what are the collection of attributes you have, then construct ER model for that. Finally, you construct a relational model. Relational model is nothing but we try to build all your entities and relationships and put the database into live. And if you follow bottom-up approach, this is a completely different approach than your top-bottom. Here first we'll understand attributes, then relations among them, then the entities, then functional dependencies. Then we apply normalization concept. Finally, we start construct relational model. And a mixed approach is a combination of this. First we do ER model, then we apply schema design, then we go for physical construction. So the physical construction we do through relational model. So any of the approach you can follow, but most of our people follows bottom-up approach as well as a mixed approach. Now, because of this schema design or database design, we are learning today is the concept of conceptual design, how you can do conceptual design or logical design of your database with the help of entity relational model or entity relationship model. So what is ER? When you talk about ER meant for entity relationship model or entity relational model. There are two parts in that. One part is entities and the other part is a relational model. There are two parts we observe carefully in this. We know as usually ER model, that means a relational model with a combination of entities, which are two parts of it. One is entities and one is your relational model. So by combinedly you can call it as ER model, which is mainly used for conceptual design, also called as logical design. There are two kinds of designs we have. One design is, please look at carefully friends, very much useful for your projects, this ER model, because when you are doing your college level project, they're supposed to ask you ER diagram. So this lecture is very useful in that angle. There are two kinds of designs are there. In your schema design, you talk about conceptual schema, also called as conceptual design. Then further, we go and do the concept of physical design. So when you are talking about a conceptual design, it is nothing but logical design only. What this logical design and conceptual design are telling you or describing us means how entities represented in the database, how entities are represented in the database, and what the physical design is talking about, how entities are stored in the database. So two different varieties. One is the representation, the other one is how you could able to store. So while you are talking about logical schema or logical design and conceptual design, they mainly see that how entities are represented in the database. As far as this concept, the ER model describes how data is involved in real world data, how it is involved. It is involved in the form of objects and their relationships. So it is also called as representation of domain knowledge. So it is called as a domain knowledge representation. The domain knowledge we are going to represent in the form of entities, relationships, and attributes. All three we are trying to use to represent a domain knowledge representation, also called as real world enterprise data. Now, what is the other importance of this ER model? When you are developing or designing any project, it is used to develop initial database design. It's nothing but analysis part, collection of things, the collection of things and how you could able to represent the things that is possible with the ER model. So this is going to be represented in the form of pictorial representation. So when you talk about the pictorial representation of your data objects, and that pictorial representation we do for schemas, entities, and relations. So ultimately, without ER model, we cannot say that relational model is really exist, because the entity relational model is telling you, and it is integrated with relational model and telling in such a way that it is mostly used how you could able to represent the things, or how you could able to design the things. And next, what are the advantages? It's a very effective communication tool for a database designer or for domain experts. And I already informed that it is integrated with relational model, and this is a very important point in the examination. Whatever is produced by ER model, it's always in third normal form. Relations produced by ER model is always in third normal, and it is very easy to understand. What are its negative side? Negative side, there is a loss of information. You cannot represent all the constraints what are there in the relational model, and it is complex for small projects. If you have a bigger projects, then you can have a good idea, good analysis, a good design. When ER mainly is talking about, you can do the concept of analysis well, and you can also do the concept of design also well. These two are mainly talking about conceptual design. Also, we call it in some other terminology logical design. So this is the terminology of ER. What is that? Entity is representing like this. Attributes are representing like this. Relationship is a diamond, and link attributes you can use. This is used for relationship, and this is a derived attribute, and this is the representation of multi-valued attribute. This is the representation of total participation. This is the representation of weak entities, and this is the representation of key. And many other terminologies are there. We also will use all these things we use while constructing ER model. In exam also, he will give you ER model. You need to identify what is its real-time equivalent relational model. Again, I'm telling you, this is called entity. This is called attribute. What is the meaning of entity set? First, let me write. There is a department table. If I say this department table has got few columns like department number and department name. So how are you representing this in ER model? This is your relational model construction, friends. So how are you representing this ER model? So entity, you have to put it in this form. Therefore, you have a department entity. So to identify that it is entity, you put it in this form. And there are two attributes are there. Attributes are being representing using like this. So take one attribute, take another attribute, write the name of attribute like DNO and DName. So therefore, friends, you need to learn that how you could able to identify entity or attribute set in ER also. So if I am giving this ER, you will understand that this is a equivalent relational model to you. Clear? Now come to next terminology. So we use in very depth case, this is a directed line, this is undirected line, this is identify weak entity, and this is identifying a total participation. This is used to identify weak attribute. This is called as a weak key. The weak key is identified with discriminator. And we have cardinality limits and a role indicator. This is a specialization and generalization purpose we use. So this is a total generalization. So you need to learn almost all terminology. What you need to learn, now I'm going to tell you, we need not learn all these things, even real time also not required. and GATE also not required. What the GATE is looking from these terminologies. So we need this and we need this. This also required. Straight line is required. This 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 is required. First page, all are required. In the next, this is required to us. This is required. Total participation is required. This is required. The remaining and cardinality is also very much required. So these are the required things. Remaining you need not bother from the above terminologies. So now let us go to another page. What the relations are there in that? The relations ER model also supports all kinds of relationships like a relational model. You can have M is to M, you can have M is to 1, you can have 1 is to M, you can have 1 is to 1. This is the representation of M is to M. M is nothing but, I am giving you, M is nothing but a straight line, 1 is nothing but arrow. So whenever there is an arrow, you can say that it is a 1. Straight line means it is nothing but what? M. So now we come to exact point. What are the components of ER model? When you talk components of ER model, there are three very much important components. Number one, attributes, entities, relationships. What are attributes? If you talk about attribute we are also calling it as a column. Also we are calling as a field. And one more thing, every attribute has set of permitted values. This set of permitted values we are calling in the form of what? A domain. For example, I am saying that student number, you can say that number data type. And I am saying student name, this time I am telling you varchar data type. So if I am saying for example 10, this 10 is nothing but you can able to enter, this is the size, you can say you can able to enter 10 characters in this. So this is what is the meaning of its domain. A domain is nothing but set of permitted values. So what are the types of attributes are there? There are different types which I want to write here briefly. Types of attributes. The types of attributes are number one, single versus multiple, which means ER model allows single attributes, single valued attributes. ER model also allows multi-valued attributes. But you observe carefully, this is okay in relational model, but this is not okay in relational model. We learned in the last series of lectures of schema design, relational model only accepts a single and it is not going to accept multiple values. But when you talk about the ER model allows single values as well as multiple values. And next, a simple versus composite. ER model allows both of these varieties. But what is the simple? This is the representation of simple and this is the representation of composite. Therefore, if I am saying student name here and this is representing first name, this is representing middle name, this is representing last name. This kind of terminology is available or provision is available in the ER model. You can accept simple values as well as you can accept composite values. But you observe, friends, very clearly, the relational model is only accepts simple values and single values. Relational model doesn't accept multiple values and doesn't accept composite values. So therefore, friends, so relational model is against to ER model in this approach. What is that? ER model allows all these four varieties, but whereas relational model allows only single and simple values. And the next variety of attribute set is stored versus derived. So if you look at this approach, what is a stored? It stores the value versus what is derived. Dependent on other other stored attribute. Therefore, what is a real-time example? All textbook speaks like this only. If I know my date of birth, then you not maintain separately what age. So your derived attribute is in the form of dotted circle like this. Then I will get what age. So this is your stored attribute. This is your derived attribute. Therefore, friends, the ER model allows composite. That means what? Earlier, two more we learned. It allows single, multiple, simple, composite, as well as it allows stored, as well as it allows derived. So this is the stored attribute, and this is what derived attribute. But relational model is not going to allow this derived attributes as it feels. A relational model thinks that derived attributes are formulas. Derived attributes are formulas. So we don't represent any kind of derived attributes in relational model, but we will accept both of them in ER model. So left side, whatever I have written, three varieties. One variety, single, simple, and stored. All are acceptable in relational model, but ER model accepts all six possibilities. Okay, friends? And next one, other set of attributes are key attributes versus non-key. When you talk about key attribute, we know that it's nothing but candidate key only. So an attribute which is underlined is a key. And what is a non-key? It's a non-key only. Simply you leave it like this. So in this, the common between ER and relational model, both of them accept key columns as well as a non-key columns. And if you talk about next, this key comes under into two varieties. One is strong key and the other one is weak key. When you talk about a strong key, this is a strong key. When you talk about the weak key, I have attribute, but I have a weak key with me, but that cannot be represented alone. Therefore, it is represented with dotted underline. When there is a dotted underline, it is called as a weak. When it is a straight away underline, it is called as a strong key. So your key comes under into two varieties, strong as well as weak. What's the difference between them? The difference is when you talk about a strong key, when I am talking about a strong key, the meaning is that can maintain uniqueness, can maintain uniqueness in the entity. uniqueness in the entity. That means we know what is the meaning of that. Duplicates are not allowed in this. Simply as simple as that. The duplicates not allowed. And when you talk about weak key, the weak key is telling you in such a way that it also needs to maintain the uniqueness, but it cannot maintain alone. Therefore, there is a requirement that weak key must depends on another strong key, another strong key to maintain uniqueness. This is very, very important, friends. You need to keep it in mind. What is the difference between strong key and weak key? Strong key can alone maintain a uniqueness, but weak key cannot maintain uniqueness on its own. So it has to depend on another strong key to maintain uniqueness. How? If I am saying there is a requirement called, this is a department instance, observe carefully, and this is a employee instance. This time I'm writing it in, I'm not writing table format, I'm writing in ER model only. So I said already, table name or entity is represented using this rectangle and attributes are represented using circle. This is the department number and there is other column called department name, and employee, there is employee number and other column called employee name. So you understand, friends, there are two tables also called as two entities. One entity is a department and another entity is employee. Now I want to say that department table is identified that department number must maintain uniqueness. So what do? We see that the department number is a key for us. When you say the department number is a key, then you underline this. And you can understand that this becomes, please observe carefully, if I remove it, this is the normal attribute only. Please understand. This is it. If I remove this, this is a normal single valued attribute only. So you want to attach primary key to that, then you're supposed to just do some small adjustment underlining. When I am underlining, then it is a what? DNO is a candidate key. And here, employee number, if I am underlining like this, it is called as weak key. So therefore you understand here, there is an employee number which stores employee numbers. There is employee name which stores employee names. Therefore, I am saying that this is key only, but it cannot represent on its own duplicates. Therefore, what is required? This weak key has to depends on another strong key to maintain uniqueness. Therefore, you are indirectly depend on department table in order to maintain the uniqueness. This time you observe carefully, your key for the employee relation, your key for the employee relation, I have a weak key with me and I am depending on the department number of other entity. So this and this together is your key in employee table. But whereas a department, it doesn't not like that. Why? Because you observe department table, it itself is identified as strong key. Therefore, it itself maintains duplicates. It itself maintains non-duplicates data. If I'm saying, for example, 10 here, so 10 cannot be given here as duplicates are disallowed. But here, as I'm making this and this together is a candidate key, now 10E1 is no problem, you can allow it, and 10E2, no problem, you can allow it. But when I'm asking once again 10 and E1, then this is going to be disallowed. Why? Because this time we are identifying DNO, ENO together is a key for us because this weak entity it depends on this strong entity. Because this is your, what I mean to say, this is your weak key. This weak key also called as partial key. This weak key also called as a partial key. So this partial key has to depends on another strong key in order to say that I am able to maintain non-duplicates data. So this is the difference between weak and strong key. So we are learning about strong key and weak case. So strong key can maintain on its own, it never depends on anybody else. But weak key always must depends on strong entity in order to maintain uniqueness of the data. So the list I have given here, you can go through it as a theoretical concept. It allows a simple and a composite attributes. So what is a simple, what is a composite? I already explained. It allows a single and multi-valued attributes. This also we know. And the third variety, stored and derived. So stored attributes, derived attributes also is allowed in ER. And the other one is descriptive attribute. So what is a descriptive attributes? For example, you talk about, this is a special terminology we have not used so far. This is called as a relation. So if this relation has any columns here, something like X and something like Y, then these attributes are called as descriptive attributes. So which are trying to record some information about the relationship. So what are the examples of attributes? So let me form few examples so that you will understand the basic terminology whatever we learned so far. Around 10 to 12 symbols we learned. Now I'm going to write few examples using those terminologies. The first one, if I am saying there is a course and there is a student. So when I am keeping like this is a table. When I am keeping like this, a table also called as, we are calling it as entity only. Now this course has two attributes, course number and course name. And this table has few attributes. One is student number and the other one is mobile number. So you know mobile number can be multiples. So when you are talking about a multiple, just draw double circle which indicates that it is a multi-value. And there is other attribute is also there, that is called a date of birth I required of the student. And there is a one more attribute I required, age. As I told you, age doesn't require to maintain. So therefore what happened? This age we are calling it as derived attribute. And one more adjustment I will do. What is that? One more adjustment. I am saying underline to this, which means it is a primary key or a strong key column. I am making this one to underline. Therefore, it is also called strong. So you understand different terminologies I have written here. I have written entity and a strong attribute and a normal simple single attribute. And this is a simple single attribute as well as it is a store because this is derived as attribute. So it is a stored, it is a derived, it is a strong attribute, it is a multi-value attribute, it is a single simple attribute. One more attribute I want to give, that is student name. We know that student name has few attribute sets like number one, first name and middle name and last name. So we understand this is the different terminology. We are calling this is as a what? Composite. This is a composite attribute, and this attribute we are calling it as multi-valued attribute, and this attribute we are calling it as a derived attribute, and what else? This attribute we are calling it as stored attributes. Remaining all you know. This is one example. Now you come to second component, that is called entity. What is entity? Entity already we wrote here. This is only your entity. This is also called as entity. So course and students are together entities. So entity is nothing but an object which is stored in the database and which is associated with the collection of attributes. What is entity? What is entity set? It's a group of similar entities. Group of similar entities. So entity is nothing but, you can say that simple term, it is an object. So when you talk about entity set like this, so course number, name, street, city is all together belongs to customer entity. For example, you talk here, there is a customer table which consists of some attributes like CNO and name and street and others like city. And now if I enter something like this, then it is called one entity set. And the next one is examples of entity. Please understand carefully. Now I am giving you, this is a project entity, nothing but a table which has got few columns here, project number and project name. This is student entity. Now we have student number and student name. So there are two different entities. Your entity 1 is project, your entity 2 is student. Now we have types of entities. The types of entities are very important, especially this is very important. So the types of entities, one is a strong entity, the other one weak entity. What is a strong entity? A strong entity can be represented alone without depends on any kind of entity. Observe carefully, friends. A strong entity is an entity which never depends on others to represent the uniqueness. Therefore, strong entity can be represented alone. So, therefore, if I am saying how you will identify strong entity, strong entity can be identified strong entity can be identified by identifying a key. By identifying a key attributes. So what is the advantage with this strong entity? The advantage this strong entity is it guarantees uniqueness. So how come? Let me show you one example. This is your strong entity. I am saying book table. Book is an instance which consists of book number, which consists of book name. Now you observe carefully. This is a normal entity. It is not at all a strong entity. Why? Because your entity does not have any key attributes. Now, if I am changing this into this side, there is a book which consists of book number and book name. So the book number, if I am making a candidate key like this, therefore what happened? This book entity is not a normal entity. It is a what? Strong entity. So what is the guarantee with the strong entity and what is the guarantee in book and a normal entity? If you take a book here, if I am taking a book number, as this is not your candidate key, therefore there is a chance of duplicate values in that. But you look at the book table here. I have a book table which consists of book number and other columns too. But I am identifying this book number as your candidate key. Therefore, you cannot give any kind of duplicates in that. So this is how it try to restrict the duplicates by specifying what I mean to say strong key. This is the strong attribute. The strong attribute forms your normal entity to strong entity. And this is a normal entity we designated because there is no any kind of a key attribute is available in book relation. You look at one more example, we'll go through it. There is an entity R which consists of something like A and B and C. So if I ask, is there any redundancy in R? Is there any redundancy in R? We can confirm here what? Yes. Yes, because no key attribute is available. If I am taking the same using a different way, that now this R is consisting something like A is identified with a key and B. Now I can say that damn sure is there any redundancy, then we can say no, because there is a what? Key attribute in that. So key attribute plays a very important role in ER model as well as the relational model. So what about weak entity? So when you talk about the weak entity cannot represent on its own. So it has to depends on strong entity. So what is the meaning of a weak entity is nothing but weak entity do not have a primary key. Weak entity has only what? Partial key only. When you have a partial key in your entity, then it is called as weak entity. So weak entity cannot be represented on its own. It has to depends on another strong entity. Therefore, weak entity do not have any significance on its own as it has to depends on strong entity. So that is a reality of weak entity. In order to maintain the uniqueness, but along with your partial key, you also required a strong key of other strong entity. So a weak entity type normally has a partial key which can be uniquely identify weak entities that are related to some owner entities. So here owner entity is nothing but what? Your another strong entity one. Another strong entity. So the primary key of weak entity set is formed with a what? Your partial key with the help of another entity's primary key. So weak entity must be represented using a total participation, also called as existency dependency. Very important this is. Total participation, also called as existency dependency. So what is the important thing you need to understand here, that a weak entity cannot be represented without a owner entity. So owner is required compulsory. Without owner, the weak cannot be represented. And this is done using total participation, also done using a one is to many relationship. Also, we are calling it as existency dependency. So either of the thing you use in order to represent your weak entity set. So either you can use a total participation, or you can use a one to many relationship, or you may use existency dependency. If you look at what is existency dependency, the meaning of existency dependency is nothing but the existency of an entity depends on existency of another entity. For example, you see, I'm saying bank database. This bank database consists of account numbers of the customers. But you see, if there are no citizens, please observe, if there are no citizens, or you can say persons, you can say person, then there is no requirement of using bank. So that means this bank database is depending on person database. So a person, whenever he is available, then he could able to take the bank account, otherwise no use of taking bank. Therefore, person database is a main requirement for us. Bank database is not a main requirement for us, because bank database depends on your person database. Therefore, in that case, we will call this is a word a strong representation. This is a called weak representation. And this is done with the help of three important things. One, you can do this representation can be done using existency dependency. There is this representation also can be done using a total participation. This representation also can be done using one to many relationship. So what is existency dependency? We will learn first. If the existency of an x depends on existency of a y, then x is a dependent, y is your owner. So here y is called as a owner or called as a dominant entity. X is called as a dependent, called as subordinate entity. So how come represents? I will show you. Listen. There is course and student. So two entities are there. So unless courses are available, students cannot join. Please observe this very important point. unless courses are there, unless courses are available, students cannot enroll. So that means you're enrolling student in the sense, you're enrolling student in the sense, you need to see that on what course or what course you obtain. Therefore, the students has to depends on the corresponding courses. So in that case, the course is called as your dominant entity, also called as owner entity. And what about student? This is called as borrower entity, also called as subordinate entity. Because this is the constraint. What is that? Unless you maintain courses, the students cannot enroll into that. Therefore, students are depending on your courses. Hence, your student is existent dependent on your course. Thus, without course, the student cannot. So therefore, unless a course is available, student cannot. Otherwise, a student depends on your course entity. Otherwise, without existence of course, there are no students. These are all the synonyms of your representation of existency dependency. So what is its drawback? We will see now. So this is existency dependency. So department is a strong entity and employee is a weak entity. And now you see employees are depending on the department. That means you want to allow some employees that employees can be enrolled into department. Without departments, the employees are not there. Please again I am telling you. Without existence of the department, employees cannot be allocated. Therefore, employee depends on a department entity. Hence here, this is existence dependency on the department entity. Therefore, friends, how this existence dependency can be formed? And what is the drawback of it? The drawback of it is nothing but if department entity is deleted, please observe. If I remove this department, there is no question of maintaining employees because every employees are associated with department only. Therefore, what will happen? If I delete any kind of entity from department, then automatically that entity will be deleted from employee too because your existency dependency on strong entity. What I mean to say? For example, you talk, there is a department 10 and some employees are working here E1 10, E2 10 and E3 10. So if I delete this 10, what will happen? These are all automatically deleted as employee depends on department using the concept of existency dependency. So this is a very dangerous situation but very useful in real time also. Why it is very useful in real time? For example, you talk nowadays our Indian government is managing centralized database which is linked to Aadhaar, PAN card, voter card, many kind of things. So if a person is expired, then instead of deleting from each and every different entities, you can directly delete from your main database. Then it will automatically remove all the cross links to which are related to this centralized database. So in that case, the existence dependency is very useful. But what is the problem with that? If unfortunately, if you delete any tuple, then automatically all its related tuples of other instances will be deleted because the other table is existence dependency on you. Let me give one example here. I'm saying, for example, this is your Aadhaar and this is your voter card. So we have voter card database and we have other database. Not only these two, many databases are there which are depending on citizen data type. We are all citizens. We will be given one social security number SSN. Real time I am talking about. To this database, a remaining all database will be linked up. Voter card, PAN card, PAN database. I am talking about income tax database. So many kinds of database which are linked to this, even your bank too. Even your bank too. Now you see, if there is a person called number 1 who is expired, then if I remove this 1, then automatically the 1 will be deleted from all its corresponding entries. It's very easy to maintain. Very easy to maintain a centralized database. So whatever action you take in the master, then automatically they will be affected to all other. So you want to represent this kind of situation. This is existency dependency. This is existency dependency. This is existency dependency. And this is existency dependency onto your citizen. So in that case, citizen is your owner, also called as a dominant. And the remaining 4, whichever I have written, they are all called subordinates, also called as borrowers. So how you are going to form existency dependency? I am saying there is author and publisher. These are the two tables are available or two entities are available. So author has author number, publisher has publisher ID. I say that without author, publisher cannot publish. Publisher cannot publish. Therefore, here what will happen? This publisher existency dependency on author. So, if you delete anything in the author, then that will be automatically affected to your publisher. Okay, friends. Now, this is existency dependency on this, and so this is a owner, and this is borrower. So, how are you going to represent existency dependency? Existency dependency can be represented in different styles. Existency dependency representation. The first style, like this: department and employee, and the relationship among them. This is the relationship symbol, and this is a one way of representation of existence dependency. Another one, this is a department, this is employee. Without a department, employees cannot work. That's the meaning. So I can use double like this. So this is called total participation. So this is also very similar to existency dependency. So you can use this kind of terminology, or you may use total participation. So we learned about existency dependency. I will also give you one more important thing. There is a department instance and employee instance. Department has department number, primary key, employee number, dotted line. What is the meaning of dotted line, friends? This dotted line is nothing but what? Weak key. This underline is nothing but what? Strong key. And this entity is a strong entity. And this entity is a weak entity. Weak entity is a double rectangle like this. So I told you weak entity cannot be represented on its own. The weak entity must depends on strong entity like this using total participation concept. So now I am using a total participation here. This is also, and the relationship becomes automatically weak relationship. So this is weak relationship that we will discuss in the next slide. So what I want to tell you, whenever there is this is a weak entity, whenever there is a weak entity is there, why it is a weak entity? Because you formed a weak attribute. Weak attribute forms an entity of weak entity. Weak entity cannot be represented on its own. So weak entity has to depends on another strong entity. Here our strong entity is a department, hence you are depending on that. You can represent like this. Now, another type of entity, associative entity. So far we learned about strong entity, which we are representing like this, primary key, and the other one we learned there is a R and S is a dotted line, then it is a weak entity like this. And the third one is there, that is associative entity. What is associative entity? Many to many relationship. When you talk, every many to many relationship to be created separate table. So whenever you create a separate table for the relationship, especially many to many, then that kind of relationship is called associative entity. It looks like a relation, but it is a what? An entity which is built on relationship. That's why it is called as association entity. How are you going to represent? You can represent associative entity like this. For example, there is a department entity and there is a employee entity, and this and this is under many to many relationship. So when there is a many to many relationship is available, you need to also create this entity separately. That's why I am creating entity over the relationship. So this time, if I name this relationship name as called works, then total you have three entities. One entity department, another entity employee, another entity works. So whenever there is a many to many relationship is there, you need to create this separate table, as we are calling it as associative entity. Very rare situations this happen only to many relationship. So this is how student is an entity, course is an entity, between them many to many relationship, then it has to be created separately as a table. So when I am creating a table for the relation, that relationship is nothing but many is to many. And the last component of your ER is, as far as terminology is concerned, relationship. So what is a relationship? It is an association between several entities. As we know from the previous lectures, relationship provides a referential integrity, and there is a requirement of foreign key constraint here. So whenever you have primary key versus a foreign key, there is a concept of relationship. This relationship we represented using diamond. There are two kinds of relationships. One is a strong, the other one weak. When you talk about the strong relationship, this is strong relationship. When you talk, the relationship is established. The relationship established among two or more strong entities. Among two or more strong entities. So, what I am saying here, there is a department, there is an employee. I am saying that department number and employee table, employee number are primary keys. Therefore, underline them like this. Therefore, it is a strong entity. It is also strong entity. So strong relationship. When I'm sharing the data between employee and department, then this relationship, we are calling it as strong relationship. So strong relationship is constructed over strong entities. This is the point. And the next kind of relationship is, this is very, very important, this relationship, weak relationship. Why we use weak relationship? Weak relationship between one strong and weak. And weak entity. Because weak entity cannot be represented on its own. Therefore, when I am talking department here and employee here, I am saying a department has a department number, an employee has employee number. This is underlined, this is a dotted underline. Therefore, this is a weak attribute and this forms entity to weak entity. This is a strong entity. This is a weak entity. Weak entity cannot be represented on its own. Therefore, you have to depend on strong entity only. So when you depend on strong entity, this weak relationship can be done using existence dependency, or can be done one is to many relationship, or can be done using total participation. This is a total participation. What is total participation? We will see later. So employee is weak. That's why there is a requirement of total participation here. So this is how you can represent weak relationship. And when you have weak relationship with a strong entity, this relationship also is a double diamond, because as it is a what? Weak relationship. So this is a normal strong relationship. As you are coming with a total participation other side, then this relationship is going to be weak relationship. Okay, friends. Now come to relationship set. It's nothing but set of relationships only. There are few types of relations are there with us. Unary, binary, ternary, quaternary, n-ary. 5 different varieties are there. Unary relation, binary relation, ternary and quaternary and n-ary. What is unary? It can be represented on its own. It's also called as self sometime. And binary requires two entities. Ternary requires 3 entities. Quaternary requires 4 entities. N-array can be anything. The other one is recursive relationship. It itself is going to have relationship. So ER diagrams are mainly for unary and binary relationships mostly we used. So how to do, friends? Let us do here. When I am saying a department instance which has got a department number, this is called as a unary. I have got only one instance. If you are talking about binary, there is a department instance and which is having a relationship with others, an employee instance. This is called binary. Two instances are being used. If I am using ternary, there is a entity 1, there is entity 2, there is entity 3, which are participated in the relationship. This is ternary. If you have n array, so several entities are involved in the relationship. So these are all entities only which are trying to participate in the relationship, as we already spoke that centralized database. So if you have a concept of centralized database here, then I can say that it is a what? N array concept. Now they are all linked to one relationship like this. They are all linked to this, and it is called as N array. And next one, when you talk about self relationship, that's called a recursion. When I am talking about the recursion, for example, I say department table is related to itself, then it is called as self recursion. You also have a recursion relationship like this, which is mostly used in many of the cases. So this is a representation of them. So this is a unary. I have A and B. Individually they are unary. If I mix them, then it becomes a binary. Recursive to itself. So recursive to the same relation A, like this. And this is a ternary. 3 entities are mixed. And this is a quaternary. And this is a n-ary. Well, friends, so we landed today the basic important things or components of ER model. Especially we learned a few important things here. What is a ER, why we are using it, and what is the advantage of ER, what are the negatives of ER, and what are the components of ER. So in ER components we learned a few important things, that there is a requirement of attribute, and we've seen several kinds of attributes here. And we also discussed about strong entity and weak entity and associative entity. And we also discussed about a relationship. There are strong relationship and weak relationship. The advantage with strong relationship is it cannot depends on others not required. It itself maintains the non-unique data or non-duplicate data known as uniqueness. But if you talk about the weak relationship, it cannot depends on its own, because every weak entity has to depends on a strong entity, and the same way every weak relationship depends on strong entity, and such kind of relationship is called as weak relationship. Please observe, friends, strong entity It does not depend on others. This is important point for the next lecture. But you observe reverse. Weak entity needs to depends on strong entity. Therefore, every weak entity must require a support of strong entity, but strong entity doesn't require any support of any other entity, because strong can be represented alone, but weak cannot be represented alone. It requires the support of strong entity in order to maintain uniqueness in the data. That's it, friends. Stay tuned to us. Subscribe YouTube channel and subscribe to Unacademy. Get the admission. Use my referral code for the 10% off, so that you will be tagged to me. So we all together working once you use my referral code for the admission. So stay tuned to us for further lectures. Good night.